Hello, welcome. Today we are going to be looking at illustration of map reduction. Illustration of what? Map reduction. There are two ways that you can use in identifying a map that should be reduced. Two ways. If you're given a scale, then the scale you're turning to is, where is the given scale? Oh, sorry. This is 50,000. So the question says, a map is drawn to a scale of what? 1:50,000, showing an area in Ghana. You understand? Now they want you to draw this same map with the scale of 1:150,000. I see this. This is 50,000 and this is 150. You understand? Whenever this one, the second, the numerator, the denominator is bigger than this one, then you need to reduce. You need to do what? Reduce. Exactly.
Yes, sir.
The given is 50,000. The numerator of the given is 50,000. Then the numerator of the one that you want to draw now is 150,000. So which one is bigger? The numerator of this one is bigger. I mean the denominator of this one is bigger. So you're supposed to do what? Reduce. Is that clear?
Yes, sir.
But these two scale, which one is bigger scale? This one is bigger. You understand? Do you know why? If you use your calculator and press 1/50,000, you know that is the meaning of this. This is a representative scale. Then you use your calculator and press 1/150,000. You see that this one is bigger than this one.
Yes, sir.
Is that clear?
Yeah.
Because the denominator is bigger, it makes it to be small. Is that clear? So whenever you're moving from source scale with smaller denominator to the one with bigger denominator, then you're doing what? Reduction. You're doing what?
Reduction.
What if you have 1:150 here and you're trying to get it from 1:150 to 1:50,000? What would it be? Enlargement. You understand?
Yes, sir.
Now, the simpler way of identifying whether you're reducing or enlarging, that's what I want to tell you now. The simpler way.
Okay.
Is that clear? The simpler way is using what we call old scale over new scale. Using what the formula what?
Old scale over new scale.
Old scale all over what?
New scale.
New scale. So what is the old scale?
1:50,000.
So 1/50,000, huh?
Yes.
Divided by
1:150,000.
1/150,000. So if you are changing the division sign to multiplication sign, what do we have?
We have 1:50,000 times 1:150,000.
1/50,000 times 150,000 over what?
1.
What?
1.
1. So we have now what? 150,000 all over what?
50,000.
So if you divide this, what do you think you will get?
You get 3.
3 back.
Yes.
So what will you get?
You get 3.
3. You understand?
Yes, sir.
So what does that mean now? If you want to reduce to this now, what do? You multiply this one by what?
3.
By 3, huh?
Yes.
That's how you get this. So let's say now that you have something that is drawn. Let's draw this in your outline. There's the cleaner. So this is what is drawn for us, which I would like you to replicate. Marianne, how are you going to do this for me now? I've already taught you about
the same size and the same dimension.
River what?
Copy it using
River what?
River more.
Well, which towns are we supposed to locate? We are supposed to locate what?
Yorin and Osha.
Huh?
Yes.
And where? So how can you, if this is what is given, and this one is the scale of what?
One is to 50,000.
One is to what?
50,000.
50,000. So now, how do you replicate it to this scale?
We draw it 3
You
times.
found out that the factor is how many times?
3 times.
3 times. The factor is 3 times, you understand? So you're supposed to reduce this one by what? 3 times. Is it not?
Yes.
So what do we do first? We measure this back.
Yes.
Is it not?
It is.
So if we measure this and this is 10 or 8 or any amount, and we measure this one and this one is also what?
10 or 5 or any amount.
10 or 5 or any amount. Let's say 12. So how do we do to produce a replica of this with the correct scale? What do I do?
Divide both sides by 3.
Good. Divide 10 by 3. You have what? 3.3, man.
Yes.
So here will be what? 3.3. Is it not?
Yes.
Then I divide the other side by what? 3 again. So here will be what? 4. Thank you. Is it not simple? Anything that you measure from here and here, you just divide by 3. Since 3 is the factor, so you draw. Huh? Now, having drawn, how do you copy this map to here? What do you do? You divide it, how many, if you want into 3 or 4, huh? Grid. Is it not? Grid line. So if this is 10, how many can you divide? How many equal grid can you divide 10 into? Let's say 5. Huh? So you have 1, 2, 3, 4, 5. Is it not? If this is 12, how many can you divide?
4
or 6. Okay. So let's say 6 now. Or even 4. 4 is into 3 times. Huh?
Yeah.
So 1, 2. Huh? So if you are using that the same way we do this one, but this one divided into how many? 1, 2, 3, 4, 5. So we do the same. Equal places, but
Yes, sir.
you can do it by just dividing this one by the number of times you want. 1, 2, 3, 4, 5. So how many? 5? 1, 2, 3, 4, 5. Back. Then this one, how many? 1, 2, 3, 4. Back. So 4 divided by 4, you'll be measuring it, which is 1, 1. 1, 1 cm. Back.
Yes.
So once you've drawn the grid, what do? You
Replicate.
start transferring, is it not?
Yes.
So to transfer, you just look at it very well. But
Yeah.
this man is here, but is it not? Then he moved down to here, then he called here. But
Yes.
then he went back here, went here, and went here. Is it not?
Yes, sir.
Do this now. So this Oloro is inside the first one, but
Yes, sir.
so now here, but
Yes.
this Tosho is in the 1, 2, but what else? Finish. So that's how you copy. So we've done 2 things. What did we do first?
Reduction.
And then copying. Map reduction and what? Copying. That's the 2 things you did, isn't it?
Yes, sir.
So write it down.